Welcome to the Tool House How-To series. My name is Chip Paulson. I'm with the Tool House. We are an industrial distributor specializing in assembly, error-proofing, material handling, and a whole lot more. Today we're going to be talking about a basic but very important function, which is how to set the clutch on an industrial assembly tool. Clutch tools come in a lot of different shapes and sizes. We've got pistol options, we've got inline options, we've got right angle options, we also have options, battery of course, and then pneumatic. The important thing with clutch tools is that you want to adjust the clutch, but then also test it. So we're going to be taking you through that process today. So now let's get into the specifics on setting the clutch. In this case, we've got the Makita right angle BFL. It's rated from 5 to 11.5 Newton meters. It's got this band here that I'm going to pull back, and this will expose the clutch adjustment area. And what's nice about what Makita's done is they have a guide here that matches up to this yellow line. So you can roughly tell where your torque is set already based in Newton meters. So if you line up this cover to the edge, and you'll see that it's roughly maybe 10, 9.5. If I wanted to make that adjustment, all you do is you turn the square drive until you find the opening, which is right there. And then there's a special tool that Makita puts in their box. You'll insert it and you go clockwise to increase the torque and counterclockwise to decrease. Then you'd want to take a look at where your yellow line matches up and see if that's the spec that you're looking for according to what your engineering document indicates. So now let's take a look at this DeSutter pneumatic inline tool. This particular tool has a torque adjustment window that you'll pop back, and from there you would insert the tool that comes with the torque tool itself to adjust, and this has some flats on it so you can insert it into the square drive, and you can turn the motor until we get to our opening, which is right there. And from there on the tool itself, it'll tell you positive to increase, negative to decrease, and you would insert the tool. You have to press a little bit hard, but then you can do your adjustment. Once you make that adjustment, you can shut the window, test it on a torque analyzer, come back, open it up, readjust it, again test it on a torque analyzer until you get the setting that you are looking for in this case. Okay, now that we've adjusted the torque tool, the last step in the process is we want to make sure that we're getting the output torque that we desire before it goes out to the assembly line. So what we'll do is we'll grab our torque analyzer. In this case it's a Crane IQ View, which is nice. It's a tablet-based system, and it's very intuitive where it's just touchscreen. You can do Newton meters, foot pounds, inch pounds, and all of the different engineering units that you need. When we're testing a clutch tool, we're going to want to make sure that it's in peak mode. There are different testing modes depending upon the type of torque tool. We'll get into that in another series in the future. So in this case, what we do is we grab our transducer, which is hooked up to our analyzer. This is a 75 Newton meter transducer. This will measure between 7.5 and 75 Newton meters. And we attach that to the tool, and what we're doing is we're testing dynamic torque at this moment. I've got it on a test joint. You can do it on a test joint, or you can do it on the actual assembly line. Doing it on the assembly line is actually better than doing it on a test joint, but in most cases you're running production. You don't want to get in the way of the operator, so a lot of people will just do it on a test joint. The other important part with a clutch tool is we want to make sure that we do have a joint kit, that we're actually running down the bolt and building up clamp load. We don't want just a solid bolt head where the clutch activates. You're not going to get the same results. So you'll see that we're running the tool down, and then the clutch will activate, and you'll see the readout. You see that we've got 9.22. We'll want to run this about 5 times. And you'll see we're right in line with where we wanted to be when we first looked, at about 9.5. So in conclusion, setting a clutch tool is quite simple. There's a couple key things that you'll want to have. That is a torque analyzer, so once you adjust the clutch on your tool, whether it's a right angle, pistol, inline, or a pistol pneumatic, you'll want to take that tool, put it on your test joint, and run that a few times. That will ensure that you have the right torque on the assembly line. One other quick thing to talk about, so with clutch tools, these are really good with all different types of joints, whether it's a hard joint or soft joint. It's kind of the workhorse of the industry, and they go up to roughly 80, 90 Newton meters down to the low inch pounds. So it's a very versatile tool. For any of your needs related to clutch tools, assembly tools, or any other industrial need, give us a call at the Tool House. We'd love to come out and see your application and help you improve your process. Thank you.